Okay, so now we're going to start on radicals. Specifically, in our case, in Algebra 1, you're going to be doing only square roots. So basically, a number that's been multiplied by itself, right, or a variable. When you get into Algebra 2, you'll be doing higher roots. But for right now, we're just going to concentrate on square roots. So today we are going to be simplifying square roots, okay? And it's a couple of steps that you need to do. It's not bad. And we will walk through it. And then we're definitely going to talk about what you need to do to make sure you're remembering what your perfect squares are. Okay, so the first thing, you take whatever number is inside the radical and you figure out what is the biggest perfect square that will divide evenly. Now, evenly means, remember, no decimals and no remainders, right? Divide evenly into the number inside your root, okay? So think of this like prime factoring, which you used to do with factor trees, right? We're going to be breaking down whatever's inside of our square root into, two or more numbers, right? Trying to find the biggest perfect square that will divide evenly and basically dividing it down. Okay. So then after you've found the number, you're going to rewrite your radical as the product of two numbers, the biggest perfect square and whatever else is left. And we'll do several examples so that you can see it. Okay, so once you rewrite the radical as a product of two numbers, basically because you have a perfect square now as part of it, you are going to simplify the perfect square number that's part of it. Okay, and again, we're doing this purposely so that we can only work with perfect squares. Okay, so you really do need to memorize your first 10 perfect squares. If you have a hard time memorizing them, basically you're going through, 1 times 1, 2 times 2, 3 times 3, grab a calculator if you need to, get a multiplication table, but you need to write out those first 10 when we're working with this. So the first 10 are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, there's some more that you can obviously go up to. You can go all the way up to 20 times 20 if you want to. But the first 10 are what you really absolutely need to have. Okay, so when you start checking to see what will divide evenly into your radicals, my suggestion is that you start with 1 and work your way up the list, right? You don't want to be bouncing all over the place. Oh, let's try 25. Oh, let's try 49. Let's go back to 16, because you might miss a number, right? Or you may end up forgetting what you've covered and you just keep checking the same numbers over and over again. So start with 1 and work your way up to find the biggest one that will divide evenly. Okay. And just because there's, certain cases where 4 will divide evenly into a number, you're not allowed to stop there. You need to keep going, because sometimes 16 or even 36 will also divide into that number. So you need to find the absolute biggest. All right. So let's try a couple of examples so you can see what we're talking about. Okay. So 40, right? I'm not even looking at the square root right now. I'm looking at the number inside of it, 40. Okay, so I'm going to go through my perfect square list and I'm going to start dividing it. 40 divides by 1, everything does. Okay, 40 divides by 4, so that's going to give me 4 and 10. Keep going. Does 40 divide by 9? Nope. 16? Nope. 25? Nope. Now here's where I can stop. Now I can stop because 49 is bigger than 40, right? So I don't need to go any further than whatever that number is. And we'll talk a little bit more later about some other kind of shortcuts that you can do as far as like how big you need to go when you divide these to find your perfect square. So, okay, so 40 basically is the same thing as the square root of 4 times the square root of 10. If you did not know this already, you can actually multiply square roots. As see, they're both square roots. When you get into algebra 2 and you start doing like cube roots and higher, they have to match before you can multiply them. Okay, it's sort of like a common denominator on a fraction to add them together. For roots, they have to be the same kind of root to multiply, but you can actually multiply roots. So the square root of 4 times the square root of 10. As I said before, we're doing purposely the biggest perfect square so that we can simplify it, right? Well, the square root of 4 is 2, and the square root of 10 does not simplify, so you write your answer as 2 times the square root of 10, or just 2 root 10 is actually how you can read it. And remember, if you don't put an operation between them, it's like putting a number in front of parentheses. It's an automatic multiplication. So this is really 2 times the square root of 10. And that is the simplified version of the square root of 40. It cannot go down any further, because if you put it in the calculator, you're going to get a decimal. We don't want decimals. We want exact answers. All right, so let's try the square root of 75. And again, go through the list. 1 divides everything. I'm not even going to worry about that. 4, no. 9, no. 16, no. 25, yes. It's 25 times 3. Okay, so that means the square root of 75 is the square root of 25 times the square root of 3. 25 is a perfect square, and yes, you could have kept going and divided by 36 and divided by 49. That shortcut I was talking about, take a look at the number that's left over. It's not going to divide again by any other perfect square, right? It's done. So we can actually stop here. So the square root of 25 is 5, and the square root of 3 doesn't do anything. All right, so let's try one more bigger number just to make sure we're good. I think that's right. Yeah, that's right. No, wait, that should be a 7. Yeah, that should be a 7. Sorry about that. All right, so we need to go through, and again, start your dividing, grab your calculator. Divides by 1, yes. Divides by 4, no. Divides by 9, no. Divides by 16, nope. Divides by 25, nope. 36, nope. 49, yes. Divides down to 49 and 3. Okay. So again, same thing. The square root of 49 is 7, and 7 times the square root of 3. Okay, and I'm going to also give you an example as far as one where you'll see that it will divide by more than one perfect square, because we do need to keep going and find the biggest. Okay, 80. All right, so we're going to go through, again, divided by your perfect squares. 1, yes. 4, yes. It's 4 and 20. 9, no. 16, yes. 25, no. 36, no. 49, no. Or again, you can see that little shortcut. That number that's left over when you divide is so small, it's not going to divide by anything else. Okay, so biggest perfect square is going to be this set right here. So if you'd stopped at 20, your answer would not be correct. It would not be as simplified as it could possibly be, because we have to keep going and find the biggest. So this is the square root of 16 times the square root of 5, which is 4 times the square root of 5. Okay, so this is algebra. So we can't just stop with numbers. We do have to work with variables as well. So let's take a look. And this is, variables to me are actually easier because you're looking for pairs. That's all you're doing. Okay, so you're going to, when you have variables in with the numbers in your square root, you are going to simplify the number part the same. That does not change, right? We're basically just going to ignore the number part or do it normal and then do the variable separately. The variables need to be split into groups of 2. As I mentioned, this is a square root, right? And to square something means to multiply it by itself, right? So that's why the square root of 25 is 5, because it's 5 times 5. So that's a pair, right? Or a group of 2. So you're going to do the same thing with your variables. You're going to split them into groups of 2, okay? Each group of 2 counts once, okay? And I'll show you why that works. And if you have any leftovers, sort of like with the numbers, when you have a leftover that does not simplify like the root 10, if you have any leftovers, they stay in the radical, right? So they get basically counted in the radical as part of the numbers that won't simplify. All right, so let's do a couple that are just variables first, and then we'll do a couple that have variables and numbers. All right, so just variables so that you can see how this works. If I have the square root of x to the 9th power, okay, I have basically 9 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9 x's, right? Because if I multiply them, right, that's what happens, is I have 9 x's that I multiply. I need groups of 2. So, okay, there's a group of 2. 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 One left over, okay? Each one of these, if you were to like write it out separately, right, that would be x squared, x squared, x squared, x squared, and x. That's your pairs, right? If you take the square root of something that has been multiplied, right, it's a perfect square basically, you have multiplied it by itself to get it. It's the same reason why the square root of 25 is 5. The square root of x squared is x. So it counts as 1, or it counts once as one basically pair of x's. So when we simplify this, I have 4 pairs and 1 left over. So I end up with 4 x's and 1 left over, because each one of those square roots, and these are all being multiplied, is basically how it works. So each pair counts once, and then anything that's left over, which means basically if you have an odd number exponent on your variable, you're going to have a leftover, and it just stays inside the root. So let's try one more, and then we'll start putting numbers and variables together. All right, so let's say we have a to the 4th and then b to the 3rd, right? So again, if you have to, write it out. It's fine. I have 4 a's and 3 b's. So I have a pair of a's and another pair of a's. So 2 a's, right? It's 2 a's, 1 pair of b's, and 1 b left over. Like I said, to me, variables are even easier than the numbers because all you're doing is looking at pairs. Think of it like playing Go Fish, right? You're trying to find pairs, and then anything that's left over just stays inside the square root because you can't simplify it. All right, so now let's do some variables and numbers together. Okay, so we have 18x to the 7th power. So we're going to do the number the same way we did before. We're going to divide it by our perfect squares to see what it will break down to. All right, so 18 going through your perfect squares. Divides by 1, yes. Divides by 4, no. Divides by 9, yes. So that's the square root of 9 times the square root of 2, right? Because the 2 is not going to break down any further. And then on my x's, I have 3, 4, 5, 6, 7. I have 1, 2, 3 pairs and 1 left over. So when we're all done, this is what this is going to look like. This square root of 9 times the square root of 2 should be 3 and the square root of 2. Okay, and the reason I'm leaving a space there is because we need to put the variable, right, that simplifies on the outside as well. So this is how you will write it. 1, 2, 3 pairs of x's and 1 left over. And that's actually how you're going to write your answer. And that would be 3x cubed times the square root of 2x. And that's as simplified as we can make it. Okay, So we'll try this one, 112 a cubed b to the fourth, all inside a square root. So again, number first, grab your calculator or your multiplication table. Divides by 1, yes. Divides by 4, yes. Believe it or not, it is, I think, 28. So 4 times 28. Okay. Not done because I know 28 will simplify more. So divides by 9, no. Divides by 16, maybe. Let's see. Off the top of my head. 70. Yes. Okay. Should be 16 times 7. I think 70 and 42. Yes, 112. Okay. So didn't have my calculator with me. So 7 is not going to simplify anymore, right? That shortcut that I was telling you about, it won't go down any further. So it's the square root of 16 times the square root of 7 is what 112 is going to be. And then 3 A's and 4 B's. All right, so let's break it down, see what we've got. The square root of 16 is 4. 7 doesn't change. I have 1 pair of A's, 2 pairs of B's, and 1 A left over. Okay, and this is how we work with simplifying square roots. All right, got one last thing to show you. And again, it's the same exact stuff. It just adds one more piece to a problem. Okay, basically, when I have coefficients with my square roots. Okay, so all right, so basically what happens is that you're going to end up multiplying, okay? What I said before about how, way back at the first example, how this is 2 root 10 or 2 times the square root of 10, right? Okay, because this is a multiplication statement. You are multiplying. There's no symbols in between them, so these are all being multiplied, okay? Basically what this means is that this is 4 times the square root of 48, okay? 4 times. I'm going to simplify my 48, okay? I just can't forget that 4 is going to actually multiply. All right, so we ready? Break down the 48. 1 divides by 1, yes. Divides by 4, it is 4 and, is that 12? Yeah, 4 and 12. Okay, keep going because 12 can still actually, simplify more. Can it be divided by 9? No. Can it be divided by 16? Yes, 16 times 3. Okay, so what you have here, we're going to rewrite it, is 4 times, we're going to rewrite the square root of 48 as 16 and 3, right? And we're going to simplify it just like we did before. I have a 4 there. Well, the square root of 16 is also 4, right? And then I have the square root of 3 left over. So when I'm finished, I do actually have to multiply my whole numbers. That's going to be 16 times the square root of 3. So it's the same process as far as simplifying. It's just you're multiplying your answer by the coefficient that's there. Okay, and yes, it actually works for negative numbers too, which we'll do one right now. I can get my page to slide up. There we go. All right, so negative 2 times the square root of 200. So again, off to the side, I'm just going to simplify my 200. So 1 divides into it. Yes, 1 divides into everything. 4, yes, 4 and 50. Yeah, 4 and 50. Okay, I'm going to keep going again because I know that still goes. 9, no. 16, yes, I think. Does 16 divide into 200 or am I being weird? 160. Oh, no, it doesn't divide into it. I'm being weird. Okay, don't worry about me. We got the next one, 25. 25 is going to be times 8. Okay, and I got to keep going because I know 8 will keep simplifying. All right, so let's see. 36 is next. No. 49, no. 64, no. 81, no. 100, yes. So it's 100 times 2. Okay, so we've got our winner as far as our biggest perfect square. That's -2 times the square root of 100 times the square root of 2. All right, simplify your perfect square. So that's -2 times 10 times the square root of 2. Finished answer, well, -2 times 10 is -20 times the square root of 2. And that's our finished answer. All right, go ahead and get started on the assignment that goes with this.